Good afternoon, everyone. My name's Ben, and I'm Kaggle's CTO. Um, Kaggle is building a platform for you to do all your data science, analytics, and machine learning projects, and both collaborate on those amongst yourselves, amongst small teams, as well as share those publicly with the world. But before I get started in talking about and demoing Kaggle, I want to get a bit of a better understanding of who you are and how familiar you are with Kaggle. So let's have a quick show of hands for a couple questions. First, raise your hands if you've heard of Kaggle before. Awesome. This will make this easy. Almost everyone has. Keep your hands up if you have a Kaggle account. Okay, looks like about half the room. Keep your hands up if you've used a Kaggle dataset before, used data from Kaggle. Looks like we're dropping some hands, maybe 10% of you. Okay, hopefully in the next week that'll be 100%. Then keep your hands up if you've made a submission to a Kaggle competition. Almost no one. One person, two people. Okay, then finally, keep your hands up if you've used Kaggle Kernels or hosted notebook product. I think 2 or 3 people. Cool. So let's go ahead and get started and swap to my screen. This session is going to be entirely demo-based. I figure you're going to be seeing a lot of slideshows and presentations over the next couple days, and I might be biased, but I love using our products, so I thought I'd give this session entirely as a demo and walk you through the different parts of Kaggle. I'd also love this session to be a bit more interactive, so if at any point in time you have a question or you want me to talk about something else, it looks like 2 microphones on either side of the room. You can walk over to one of those and ask, or just raise your hand, get my attention, and shout it down to me, and I'll repeat your question so everyone can hear. When you log into Kaggle, kind of the first thing that you see is a newsfeed of all the public activity that's going on in Kaggle. And you'll see that there's a really kind of rich array of comments about and code being shared on data, analytics, and machine learning. This is because we have a community of nearly 2 million users, and they're all of whom are people who want to learn more about data and who love using data in some capacity. And there's 4 core parts of our platform. There's competitions. We see these in the header. Competitions, which is where we got started. It's a place for organizations ranging from commercial users to nonprofits to research groups to publish supervised machine learning problems through Kaggle in a way that our community competes to develop the best solution on those problems. That's where we got started about a decade ago and is our oldest product. We also have Kaggle Datasets, our public data platform, which has about 8,000 datasets that have been shared with the world on that you can go and consume. And these cover a huge range of different topics, from cryptocurrencies and financial datasets to tweets of different people to a bunch of computer vision datasets. The third core part of our platform is Kaggle Kernels, which is hosted Jupyter notebooks, and we'll dive into that in much more detail in a little bit. And then finally, since many of our new users come to us to learn to improve their skills with analytics and machine learning, we really recently launched a new section of Kaggle called Learn, which is a set of short, bite-sized tutorials that make it really fast and easy to get started with analytics and machine learning and teach you just enough to get you off the ground and let you start working on your own projects. And diving into your own projects is really the fastest and most effective ways to learn how to apply machine learning and improve your skills there. So to kick off, we'll dive into competitions. When I click into competitions, I see all the active competitions that we have on this site right now that have large prize money sponsoring them. And just to give you a sense of the array of different competitions, the first one I see here is on identifying salt deposits between the Earth's surface. This is a really important problem for the energy industry in oil and gas exploration and drilling, in that seismic datasets are both very large and are very challenging to identify what's the salt deposits in those, as well as more of the underlying geological structures. The next two here are both with the financial services industry. The first is focused on home credit default risk. So can you predict the likelihood of applicant repaying their home loan? Then the second is with Santander Bank on predicting the value that transactions of potential customers will bring for them. The fourth competition is actually with Google AI, and it's a complex object detection problem. So focusing on identifying dozens of different objects in an image and identifying where what the objects are, as well as where they are in the image. And then finally, on the research side, the fifth one that we have shown is with CERN, and it's on applying machine learning to improve our ability to track particles in the Large Hadron Collider. So you really see from this kind of the range of different applications that we currently are applying machine learning to, and we're exposing these problems to the world. I'll click into one of these to go into a bit more detail. So this is the home credit default risk competition, which is a $70,000 competition where we've released an anonymized data set here of a lot of information on loan applicants. And as you look through this, every machine learning problem starts with a rich and hopefully high quality data set. You'll see many of the things that you'd expect. I can click through here and I see that we've split it off into a train set that you can use to train a machine learning model on for the different applications, and then a test set that we use to evaluate and score how the machine learning model is doing. If I scroll down a bit farther, I can see a rich data visualization here. That's a nice preview of what's in this data set. You'll see some of the usual suspects like income, what type of loan are they looking for, and things like that. As well as you'll see a lot of the data that can be helpful for predicting the likelihood that they'll repay their loan. For example, what is the credit card balance, and what other loans do they have out, and things along those lines. Then you see here that 5,000 people have participated in this competition so far. That is one of the really unique things about being able to pose a machine learning problem publicly. It's the difference between having one group of people or a small couple teams collaborating on the problem and having 5,000 people from all around the world being able to focus on the same problem and both collaborate and compete to get the best possible result on that. And this 5,000 teams isn't just from the US. They're not just people who have machine learning PhDs from Stanford. Instead, they'll include things like a English major from a school in Germany, or a retired physicist who wants something that's more entertaining to do with his free time from Sudoku. So it's a really diverse and international set of participants that really helps to democratize both the raw data machine learning problems, as well as the ability to apply this technology to everyone around the globe. If I click through to our discussion forums, I'll see that there's a really rich array of discussion on this problem that's really in-depth looks at specific considerations in structuring this as a machine learning problem and cleaning the data, and what methods tend to work well on this problem, and things like that, where the community is helping each other out. Then I can also see how everyone is currently doing on this problem by clicking through to a leaderboard. And I'll see here the score of how people are doing on this problem. In this case, users are predicting the likelihood of a person paying back a loan. And this is scored using a machine learning metric called the area under the receiver operator characteristic curve, or AUC, where 0.5 is random and 1.0 is perfect. And then you see here that the top teams are clustered very close together, where you have to look in the third digit to see a difference between many of the different top teams. This is one of the things that we see from having many different groups around the world independently working on the same problem. They really find all the signal that's present in the problem, and the rest tends to be noise that's either inherent to the data set itself or beyond the current state-of-the-art machine learning to handle. So let's say I wanted to get started on this problem myself. How would I go about that? The first thing I need to do is get access to the data, and there's a couple different ways I could do that. I could click download and download the data and start working locally. We have an API as well. I could run a command line command to pull the data down. I could also use a new tool that we developed called Kaggle Kernels. I can drop in, click new kernel here, and what's going on behind the scenes right now is in a Google Cloud VM and in a Docker container within that VM, a new Jupyter Notebook instance is being created for me. And then this instance isn't just a vanilla Python instance. Instead, it has both the data preloaded into it as well as all the libraries that I may want to use. And as a quick example of that, I'll go ahead and give this a title. Again, import pandas, which is a really nice library for reading in and manipulating tabular data. I have things like TensorFlow pre-installed. I have Keras in there. I can pull in my favorite gradient boosting library, XGBoost. I can pull in a plotting library. Who here has had trouble getting the right Python libraries installed before and gone through a lot of headaches around that? Okay, probably about a third of the audience, which is probably the third that seriously worked with Python in any capacity before. So notice how by having this in Docker and having this running on a cloud VM, I remove the installation pain from my work. Out of curiosity, how many of you have seen or worked with Jupyter Notebooks before as well? Quick show of hands. Okay, great. It looks like about 3/4 of you have. For the quarter that haven't, Jupyter Notebooks are a really nice tool that have kind of become the default IDE that analysts and machine learning engineers and data scientists and that type use for interactive data exploration. They're nice because they let you interleave code, markdown, and the kind of graphic results and visualization output side by side in a seamless way. But one of the things that's tough with them by default is versioning. And one of the things that we've added to this is the ability to hit a button, then have a clean end-to-end version run created. They can then take that and share it with my teammates. They can fork it and reproduce it very easily, or I can click publish and share that with the broader world. Another extension that we've added on, you'll see if I type something like A equals hello next, I'm surfacing my interactive variables here so I know what I've loaded into RAM and what I currently have available to work with. Finally, you'll see that I'll have access to the same set of data previews from the data set that I've loaded into this. And if I wanted to do something like see what's my training data or load that in, then I can copy that. I can see the histograms for what's in it, as well as a quick preview of the data while I'm working with it. Then pull that, then use pandas to load it into memory here. I see that I have that pulled into memory now, so I can continue to work with that programmatically. If I wanted to, I can drop in, I can share this kernel with my teammates who could start working on it. I could also add a GPU to accelerate my analysis. I could add additional data sources if I want to join to other data that might help me with this problem. I could reference both public data that we have, other competition data sets, as well as the output of any kernel that's been published on data on Kaggle so far. And then finally, if I have a use for having an internet connection, we block internet by default to encourage reproducibility and reproducible analytics workflows. But I can easily click another button and have internet enabled on this instance. But I want to step out of the interactive environment now and drop back into the benefits of having an environment like this that's available for our community. Now that I click through here for this competition, I can see hundreds and hundreds of code examples that other users have created and published on this data set. For example, this user here made a really helpful introduction to new users to this problem for here's the data, here's a nice diagram and some details for how the data is structured. Here is the evaluation metric for my machine learning model, the area and do the ROC curve, as well as how that works. Here's how I read into that data into my notebook. Here's some exploratory data analysis consisting of things like how to do one-hot encoding to encode the feature vectors that I can use as an input to my machine learning model, as well as here's some univariate relations. For example, here's a distribution of how likely people are to repay their loans based on how old they are. Probably it's not going to surprise anyone that younger people are slightly less likely to repay their loans than older people. And then if I keep scrolling down, I continue to see that this user's done a very rich, both exploratory data analysis, as well as has showed how to train a number of different machine learning models on this data set. So when I start working with this problem, it's not like I'm starting with just the raw data or an empty cursor. I have the benefits of all the work that other users have created on the same problem, then I can read those and leverage those as a starting point. I see here that this kernel has been very popular. Over 200 people have left comments on it. This user's ran 15 different versions of it, which I can click through and see if I want to understand how he's developed this over time, how the different versions have progressed, as well as over almost 2,000 people have forked it and then taken this and built on this and used it as their own starting point. And when I press fork, what's happening is I'm spinning up the same environment that this user is using when he created the kernel, and then that makes it really easy for me to reproduce his code. So I can go through here, then I see none of my cells have run so far, but if I hit run all, it's going to run this notebook top to bottom. It's going to start loading in the data, and then I get the same set of information that this user had created available and reproducible with a click of a button. Out of curiosity, how many of you have had trouble reproducing work that you found before, either online or in literature, or some random code example that was shared as a guest at GitHub, or et cetera? Yeah, it looks like most of you have. So one of my goals over the next 5 years is to make 0 people raise their hands when I ask that question again. Then you see here, this is continuing to run through, but this end-to-end reproduction should work seamlessly thanks to underlying technologies like data versioning, code versioning, and versioning the computational environment through Docker containers. When I click out of this, and that's a segue into the next part of Kaggle, our open data platform. So this part is a part of Kaggle that we launched about 2 years ago. And in the past 2 years, our users have published nearly 10,000 data sets on Kaggle, many of which are really high quality and well-curated data sets that they've shared with the world. If you want to work with your own data on Kaggle, it's really easy. You click New Data Set, and then you can either drag and drop files to upload them. You can use our API to publish them directly from the command line. And you'll have a couple options as well. You'll put a title in. You can choose whether it's private or public. Many users start off with private data, then keep it private as they're working on their own side projects and hobbyist projects for their own work. Many others start private initially to upload it, work on it a little bit, to clean it up, and then ultimately make it public to the world. And then just to give a couple examples of some of the different types of data here, you see that ranges from New York City public data to things like sports results to this is a good computer vision data set for different species of monkeys here and being able to go through and identify the different species of monkeys like this one. And then if I want to pick different topics and find data appropriate for my problem, let's say I'm working in a financial problem, I might be interested in stock data. I can do a quick search and see that there's over 100 data sets that have different variations of both US and international stock data. Another area that's been popular recently is Bitcoin, so I can see that we have a number of cryptocurrency data sets available as well across several different currencies. If I'm trying to train a computer vision model, I might be looking for image data, so I'll search for images and see what I have available as a starting point there. It could also be, say, trying to train a sentiment classifier on an NLP problem. Then I can see that there's hundreds of starting points for sentiment analysis and text classification that I can take and leverage. I'll pull a couple of these up in a bit more depth. The first will be a movie data set. And then when I click in this data set, first I can see very quickly what's in the data itself. In this case, this one's metadata on almost 50,000 movies with 26 million ratings from over 270,000 users. I can go in a bit more depth and see that it includes the things I'd expect, like who's in the movie, what's the cast and the crew, a lot of metadata with a movie. For example, what's its budget, how much money did it make, what language is it in, here's a quick summary of the movie, how popular it was, a lot of things along those lines. And then as well as a ratings data set where the hundreds of thousands of users rated these movies on a scale of 1 to 5. Then the other unique thing about publishing data on Kaggle, two other unique things is first, we version everything by default, so you don't have to worry about versioning, or if you do an update to the data set, then it's really easy to see that you did the update and then to understand what happened. One of the really common pain points that we've seen is different users or different teams are working on different versions of the same data set and aren't aware that they're working on different versions of the same data set. So one will change in one place but not change it in the other, or they'll update the data set but not the description and things like that. So one of our goals is to make it really easy to see when the data changed as well as what changed with the data. The second thing is we have kernels available on data sets as well, and we have a way to go through and for any data set, see all the code that's been written and shared publicly on that data set. So again, for any data that you publish, you don't just get the advantage of here's a quick way to publish and share data online, but you actually see the results that users create on that and the analysis that they create. One user here trained a nice set of recommendation engines and gave examples of how to do both popularity-based, content-based, and collaborative filtering approaches to movie recommendations in here. And if I wanted to take that and reproduce it and extend it, again, I could click fork and run with it just right from my browser there. Another user, whoops, open that twice. Another user here was interested in some of the history of film and looked back at things such as where did the movies originate from, and what are some of the most popular and highest grossing movie franchises of all times. So for answering questions like this, if I was coming at this from another angle, I'd just be working with this data set, a random CSV file I downloaded off the internet, pulling it up locally, then doing all this analysis myself. Instead, I have the benefit of going through and being able to see all the analyses that other people have created on this. So I can both use this as inspiration for my own work and don't need to repeat work that others have already done. Another of my favorite public data sets is one that we release ourselves. So we make all the data that we can, or most of the data that we can make available publicly on Kaggle. So things that show up on the data sets and competitions, or the public versions of each of those, available to our users for analytics. So I can see things like, here's a CSV file of all the public competitions that we've hosted. Or to get a bit meta, I can go in here and see, here's the different public data sets that we have, and I can actually find this data set in a data set here where I see this little row represents the data set that I'm currently seeing on this page. And we've really been blown away by how all of our users have used this. Whoops, looks like this is down, but this is a really actively used data set. We see dozens and dozens of discussion and analytics created on it each day. Two examples of those are one user wrote an automated kernel to pull out where are all the winning solutions of Kaggle competitions. Many users will publish their winning solution in a forum post with a link to the code that they used to create it. So this user went through and searched, pulled out for all of our popular competitions. Here's the things that say solution in the title ordered by number of upvotes and kind of the activity on it as a quick way to identify. Here's a list of hundreds and hundreds of highly competitive state-of-the-art machine learning solutions that have been created and shared on Kaggle. So if I want to work on something like iceberg classification for satellite images, I can come to this kernel, I can click on the winning solution for that, and then I can quickly understand what is the state of the art on this problem, as well as how did this team approach this, not just in theory, but in practice. How did they segment the data and analyze it, and what did they do that worked? In a similar vein, another user realized that we have a lot of people sharing really helpful tutorials for how to do various analytics, machine learning, and AI projects and work on Kaggle, and created a set of topics and then pulled out, here's the best kernels on Kaggle for each of these topics, ranging from linear regression, logistic regression, to XGBoost, to deep learning and convolutional neural networks, to clustering algorithms, through to a lot of other things that don't get a lot of buzz but are really important for anyone applying analytics and machine learning in practice, like doing high-quality exploratory data analyses so you understand what's actually in the data set that you're working with and how to do feature engineering and components along those lines. Again, one of the cool things about this is that this isn't something that they had to go through and manually pull together. Instead, they were able to create this analyses on our public data set in a way that's automatically produced and updated over time. Okay, I'm going to go ahead and go into the last bit of Kaggle for a little bit, and then open up back up for questions at the end. We'd heard from many of our newer users that they really wanted more material to get started in data science and machine learning. So about 6 months ago, we launched a new section of Kaggle called Kaggle Learn that's run through Kernels. And then this is a set of about 10 different courses, each of which consist of around 5 to 10 different tutorials and exercises that take a week to go through, covering areas like Python for analytics and machine learning, or using SQL as a data scientist, or here's how to get started with your first machine learning models. And our goal for these is to teach you just enough that you can use to get started with your own machine learning work, and then to get you onto your own projects as quickly as possible, because we believe that you learn the most from starting to work and figuring out what works and what doesn't on your own projects versus spending a lot of time following a very structured course and curriculum. So just as one example of these for starting the first machine learning project, this is on we used a house price prediction data set for this, where based on things like how large the, how many square feet is in your house and components like that, how many bedrooms do you have, predict the sales price of the home. And this is also something we're considering how to take community contributions from as well. So if you're inspired to use Kaggle as a teaching platform, then I'd love to speak to you afterwards. I encourage you, if there's an area of analytics or data science or machine learning that you want to explore more of, to check out Kaggle Learn and to get started there to start applying it to your own work.